Welcome back, everyone, to theCUBE. Day 3 of our Robotics and AI Leaders series with theCUBE and the NYSE Wired community, an open community of trusted voices of people who are sharing their knowledge with you. We've got a great guest here, Dr. Andrew Clare, CEO of Elroy Air, doing some amazing work in, obviously, robotics, I'll call it aerospace, but with AI and all this stuff happening, you're starting to see the acceleration. Dr. Andrew, thank you for coming on. I like to add the doctor and then you get a PhD, so thanks for coming on.
Thanks for having me today.
First, I want to get into some of the things you're working on, some of the challenges, and a lot of action happening with robotics. AI is helping a ton with that. We just came back from GTC, AI Factory, starting to see AI infused in with hardware. Big part of the theme here. But first, set the table. What are you guys working on? Give us an overview of what you guys do and the product that you make.
Absolutely. Elroy Air is building large cargo teleportation. We fly things from A to B autonomously. And we're proud to be a dual-use company. We're tackling the $160 billion medium-range commercial logistics market and the $8 billion defense aerial logistics market. Now, our first product, the Chaparral, will save time, money, and lives. It's the autonomous pickup truck of the skies, an uncrewed aircraft that can carry 300 pounds of cargo and fly 300 miles. Takes off and lands vertically, using distributed electric propulsion so it can be deployed anywhere, including the ships, and then cruises at well over 100 miles per hour. And one of the really unique things about the Chaparral is that it uses a hybrid electric powertrain. So it runs on standard jet fuel, major advantage to utilizing existing infrastructure, and there's no need to install chargers. And in fact, we were the first company to ever fly a turboshaft-powered hybrid electric aircraft back in November of 2023.
That's awesome. So first of all, I mean, this is working right now. You have military contracts. Give us the state of the product. It's out there. It's working right now, shipping, moving goods from point A to point B.
Great question. We have 1,000 aircraft backlog on the commercial side with marquee customers such as Bristow, LCI, and FedEx. On the defense side, we have multiple active paying contracts today. Our aircraft is still in development as we continue to expand the flight envelope of what it's capable of, as well as autonomous capabilities. And we're aiming to begin customer integration testing within the next 2 years.
Awesome. Give us some background on when you guys started. When did this all kind of come together?
Great question. Elroy Air is an 8-year-old company based out here in the San Francisco Bay Area. And we've been working on this product for the entire length of the company. We've been flying our full-scale aircraft successfully for the past 18 months. And we've been working especially on our hybrid electric powertrain for the past 4 years, which recently has become much more interesting, especially in the defense community, as we see the benefits, including less infrastructure changes required, longer ranges, higher uptime and utilization of vehicles from a hybrid electric powertrain.
You know, one of the big things, Andrew, is we're hearing in these interviews is skill gaps. I mean, obviously that's been a tech conversation for, obviously in the industry for a long time in other areas, but specifically around autonomous manned vehicles, any kind of human in the loop actually adds complexity, but also finding them. So talk about those two dynamics, because that seems to come up a lot. Obviously, moving stuff around autonomously has that advantage, but also it's not just flying packages around, it's big payloads. Talk about that dynamic of the labor aspect, both from who's skilled to do this, operate them, but also the benefits.
Absolutely. We have been designing our aircraft to be autonomous from the get-go. It's uncrewed. There's no room for a person on board. And that means that we've had to solve really hard challenges in terms of how the aircraft is controlled and also how to make sure that it's safe. But once our product is deployed into the world, there's two major benefits that come from having an autonomous aircraft. The first is safety. We firmly believe, when you look at the data, that today the vast majority of crashes are due to controlled flight into terrain or due oftentimes to human error. And so the ability to really bring the safety benefits of autonomy to flying is really important. The second, of course, is cost. For our commercial clients, one of the things that they really see as a benefit here is the ability to provide a much more efficient service to their customers in terms of moving goods around. And then for our defense customers, you don't have to put a single human life at risk if you're moving goods around in a contested situation. And that's one of the really key value propositions of the Chaparral.
Talk about the use cases. How's this kind of develop? People call it, hey, I need some, I need some product. I mean, there's obviously low-hanging fruit use cases. What are some of the things that you guys saw immediately as you started to see the demand kick in, and what were some of those specific requirements? I mean, obviously, probably teams inside your customer base. There's no real department yet, but probably are developing skills to figure out how to source requirements. What are some of those use cases?
Yeah, well, let's go through all three of our verticals. We have the commercial sector. We have a lot of demand also in the humanitarian sector that I'll speak about, and then the defense sector as well. On the commercial side today, around the world, a lot of goods are moved by aircraft, whether fixed-wing aircraft or rotorcraft. And these are really expensive assets being flown by highly trained pilots, oftentimes to move very small quantities of goods around. And so immediately upon talking to our customers, that's the reason we have this 1,000 aircraft commercial backlog. It resonated deeply with them to say, let's have an uncrewed aircraft that's autonomous, such as the Chaparral, that can do this at a much lower cost point, much more efficiently, without utilizing these very large, very expensive aircraft to move goods around. Some of the use cases that really resonated quickly are offshore work, flying over hard terrain, such as mountainous regions, as well as the ability to move goods that have some kind of express or urgent need to get there quickly.
I mean, that's awesome.
On the humanitarian side, a lot of interest in, let's say there's a natural disaster or a hurricane or some situation where we need to get food and water supplies in quickly to an area that doesn't have a lot of infrastructure. The ability of the Chaparral to land and take off vertically means that it can land anywhere, and we can really get goods to those in needs.
Before
on the defense, yeah, please go ahead.
No, go ahead. Stick to the defense part.
And the final side on the defense side, as I mentioned earlier, we have lost so many lives over the past 25 years due to putting our soldiers in harm's way just to move goods around, let's say driving in a Humvee or moving packages around. Logistics is so key to any effort in the Defense Department. And the ability to do this now with a fully uncrewed aircraft that stays out of harm's way, never puts a person at risk, is a value prop there.
You know, I mean, the tactical edge is a really important point. I'm glad you brought that up. Certainly on the defense side, we've been covering that a lot with the JEDI contract with AWS. You know, technology is going to be very key. I want to get into the technology piece now, but I want to first explain the size and scope of the vehicles that you're autonomously moving around. Size, payload that they carry. What are some of the specs?
Yeah, the key specs of Chaparral, it can carry 300 pounds of goods. So that's the useful payload of this aircraft. It can fly 300 miles, and again, that's enabled through our hybrid electric powertrain. To size the aircraft, think about a 26-foot wingspan or so. And so it is a much larger than your typical small unmanned system or drone that you might be used to. It's far more capable. Yet one of the really interesting things about this aircraft is that we've designed it to be stowable. You can rotate the wing, fold down the tail, and fit this aircraft into a standard military transport aircraft or a standard shipping container, so it can be rapidly deployed anywhere around the world.
Yeah, that's what I call a co-pilot right there. Really, really interesting tech. Now, people see self-driving cars. They go, wow, that's awesome, cool. Robo-taxis are hot. You're starting to see them hit the scene. What's some of the tech involved? I mean, obviously a lot going on with the physical device, the product itself. Inside the product, you must have a lot of computer vision, all the bells and whistles. Explain some of the tech and behind the scenes here, what's going on inside the unmanned aircraft.
Absolutely. Well, we've designed our aircraft to use onboard sense compute, and in some cases also aspects of computer vision and artificial intelligence to be able to do a few different maneuvers. First is identifying viable landing zones, making sure that those are cleared and safe for the aircraft to touch down. Also, to make sure that when we're flying around as an unmanned aircraft, that we detect and avoid other aircraft around us so that we can operate safely in the national airspace. Finally, on the ground, we've also implemented and demonstrated robotic logistics efforts on the ground, such that our aircraft can autonomously navigate, find the cargo pod that it's trying to pick up, and then pick up that pod on its own. And that really enables highly efficient, unattended ground logistics for delivery and pickup.
What kind of technology you guys using? Is there a supercomputer involved? I mean, what kind of compute, what kind of hardware is in there? You must have a lot of horsepower needed. How do you guys look at the back end? How is this architected?
Yeah, we use a very, very power efficient compute on board, given the fact that this it needs to be lightweight for an aviation application and also very power efficient. And we really utilize these kinds of sensors only in specific scenarios, as I mentioned. So whether it's on the ground for logistics, whether it's clearing the landing zone, or then just general flight around to make sure that we are detecting and avoiding other traffic. And so in any aviation context, making sure that you're on very power efficient and low weight, very
Yeah,
important.
yeah. I love what you guys are doing. I think it's awesome. You mentioned safety. Safety first is a big theme, obviously, in any kind of autonomous situation, whether it's a driving truck, car, or aircraft in this case. But as you guys look at the market and future, you got to have contention and congestion issues. How do you guys think about that in the context of safety? What are some of the things that you guys are doing? Can you scope kind of like what goes on around the tech you got to build, the procedures, the requirements, some of the things that you got to do to check the box, so to speak, to kind of be, super secure?
It's really important. One of the things that I focus in keenly on are both the cybersecurity aspects of what we're doing, as well as ensuring that we are a good steward of the airspace in which we fly. And as you mentioned, as there are more aircraft flying in the skies or even on the ground, as we see more congestion on the ground, we see an opportunity here to utilize the skies for the movement of goods to maybe relieve some of
Yeah.
that congestion on the ground. And I think this is going to be a really key point as we see growth in both logistics space and the demands from customers for express shipping over the coming years.
Talk about the role of software and hardware, because so much is going on. I mean, I can just think of a zillion questions. I don't want the drone to fall out of the sky, or not drone, aircraft fall out of the sky with all that payload. You got to navigate around people or certain things, objects on the ground and in the air. What's the software hardware relationship? How do you guys see that building out? Is there any kind of secret sauce that you have, or certain architecture that seems to work well for you guys as AI comes on? More and more LLMs, more foundation models are coming in. You guys are utilizing computer vision, again, another growing area in AI as well. What's the software architecture, hardware software architecture look like?
I'm incredibly proud of the software that we built here at Elroy Air, and it's quite advanced in two specific areas. The first is in power management. As I mentioned earlier, we were the first to fly a hybrid electric powertrain, and that actually requires quite a bit of differentiated software where we have a number of both patents and some IP protection there that allow us to operate in the different modes of flight associated with a VTOL aircraft. That includes takeoff, landing, cruise, transition, etc. And the power balance between the turbo generator system that's producing electricity, as well as the power generated from our batteries, needs to be balanced very carefully in order to power the distributed electric propulsion system on our aircraft. Beyond that, I'm incredibly proud of the software that we've developed, as I said earlier, for the ability of our aircraft to autonomously navigate both on the ground and in the air. And so when you look at the kind of aircraft that we're building, it's designed to be highly reliable, where we don't have a lot of moving parts on board, and that
Yeah.
actually is enabled by the software that we've developed.
I love that simplicity. Kind of makes it more efficient. Talk about what you guys are looking for when you're hiring. I can see a lot of hard problems you're working on. It's cool and relevant. It's certainly an obvious growth area. You guys are nailing the safety. You got backlog. I mean, you guys must be busting out. What's the criteria to work there? I got to be a physics major, aerospace engineer, software developer. What are some of the skills you guys are looking for? Because I'm sure that people always want to find places to work that solve hard problems. You're certainly in the zone there, so to speak.
Great question. Well, we're actively hiring right now, and what I look for when I'm hiring are three things. The first is evidence of distinctive technical contributions in their past life, whether in school or in a previous job. I'm really looking for folks who have done incredible work solving really hard technical challenges. The second thing I'm looking for is passion. I want somebody who gets up every morning excited about the product that we're building and excited to serve our customers, get this out into the world and have a real impact. And the third thing I'm looking for is someone who is a great collaborator, right? We work so closely at our flight test facility, at our headquarters, building and designing this. We have a lot of partners, suppliers, customers that our employees interact with every single day. Collaboration is key, and so that's the third thing that I look for.
Awesome. Well, I really appreciate the time you bring on the cube here. Love that commentary. put a plug in for what you're optimizing for, what you're working on, what's on your mind these days. What's the roadmap look like?
Yeah, as I mentioned, the Chaparral is really the uncrewed pickup truck of the skies. We have incredible traction on both the commercial and the defense side. And as we look to scale production of this vehicle over the coming years, we're really looking for folks who are excited about the mission of what we're building, see real use cases out there where this could benefit your customers, and we'd love to hear from you.
Andrew, thanks for contributing with us here on the Robotics AI series of leaders, and congratulations, and love what you're working on. So very cool and relevant, as they say. Thanks for coming on, appreciate it.
Thanks for having me.
All right, this is theCUBE coverage here. The NYSE, the Wired, and theCUBE working together to open community of leaders sharing their knowledge on the most important and cool and relevant things happening in the world of AI and of course robotics. Again, a lot of AI, a lot of tech involved, but this is real world impact, and we're going to continue to bring the coverage after this short break.